welcome everyone. Today we're going to be in our next session for Build with IoT, which is how to leverage the newest features of the Particle IoT platform as a service. My name is Dan Kuba. I'm a senior solutions architect here at Particle. I've been with Particle for almost 3 years now, and I work out of our San Francisco office. Eric, would you like to introduce yourself?
Yeah, I'm Eric Brisseth. I'm a Device Solutions Engineering Manager. I've been with Particle for a little over 2 years, and my group just works with the Tracker 1, Monitor 1, and Tracker M.
Thanks, Eric. All right, I'd like to start with a quick agenda today. We're going to start with an overview of our platform as a service offering. We're going to start at the bottom of the stack, talking about what we built in the last year at a platform level. And these are going to be features that are available to virtually all users of the platform. Moving up one layer, we're going to get into the details of our tracking platform, specifically with Tracker Edge, and some of the upcoming investments we're making there. I'm excited to have Eric Brisseth join me today to talk about a new customer requested feature, which is Store and Forward, and will soon be released in Tracker Edge, and will be eventually released as a general library for all users of the platform. Next, we're going to go up even one more layer into user applications, and I'm going to share some progress towards a reference application that I've been working on, which will allow you to quickly get our Tracker ecosystem up and running with any CAN bus connected assets. And finally, we'll close out the session and get to some of your questions. Please use the Slack channel that's on this slide to post questions throughout the session. We're going to, once we're done with the presentation, hop into Slack and have a live Q&A with you all. We've got a lot to cover today, so let's dive in. I'm going to start by setting the stage for the content I'm going to share today, talking about Particle's platform as a service. We're going to start with the 3 pillars of IoT. Our core offerings of hardware, connectivity, and cloud, all under one roof, are the foundation for any successful IoT deployment strategy. However, our platform as a service is a lot more than just that. Our software and firmware is constantly evolving, and we're continuously investing in our cloud platform and device OS to bring you the latest and greatest features. By partnering with Particle, you're co-engineering with us. We'll handle the details while you build business value with our solutions. And finally, Particle is making verticalized investments. In our over 9 years of supporting our customer IoT deployments, we've come to understand both what makes your use cases unique and also what technologies and deployments you have in common. As Zach and others have spoken to at points during Spectra so far, we've turned this knowledge into targeted products and hardware development kits to help you build and deploy more quickly. Let's take a look at some of the investments that we've made in our platform in the past year. These are available to anyone who uses our modules in our cloud, regardless of vertical, use case, or module type. Over-the-air updates, or firmware over the updates, is one of Particle's killer features, and we're continually investing in it. From this year, we've added 2 great new features with resumable OTA. Huge benefit for OTA and power-conscious or connectivity-constrained deployments. OTAs are now sent in chunks, and the system can pick up where it left off in the case of a disconnect or other failure. We've also introduced wildcard firmware, which enables a user not to have to specify the product ID in their firmware at compile time, and instead be able to use a single binary for multiple products that use the same platform. We've released a bunch of really cool new tools. There's a whole new tools section of our documentation site as well, and I'd like to give a special shout out to Rick Asaguma, who's built most of the tools that you're going to find there. Some key ones to highlight today: we have some new debug tools, which help you diagnose connectivity issues with just a browser and a Bluetooth connection, or USB if you prefer. We have some setup tools that are great for setting up prototypes on your desk and getting up to speed with the platform, but also are useful when you're managing firmware on your manufacturing line. We also have a new data usage tool, which allows you to pick a device or product and see the data that it's consuming in megabytes over time. With Device OS in the past year, we've maintained both the 2.x long-term support and 3.x feature lines, and in line with our definition of LTS, we've backported critical fixtures from the feature line into the 3 minor revisions of the LTS line. We've also increased the binary application space for your application so you can have larger user apps and run more at the edge, from 128 kilobytes to 256 kilobytes on all of our Gen 3 platforms. Now, yesterday, my colleagues Arjun and Manuel gave a deep dive into the concept of a data operation, which is something we unveiled last year at Spectra. Now, in working with many of you over the last year, we've seen how much easier it is to forecast your usage for your particular use cases using data operations rather than going into the details and counting bits and bytes. And this is further emphasized by the included features such as OTAs, pings, keep alives, and a lot of the other under the hood stuff. We've recently released a usage reporting API that allows you to slice your usage in your data operations by device rather than by your entire fleet, giving you more visibility into how your fleet is operating in the field. We've also increased our payload sizes. As a testament to our commitment to provide continuous value to our customers, we've expanded the volume of data that's available for each transmission in each data operation from 622 bytes to 1,024 bytes, allowing you to send more data in fewer packets. Bluetooth Low Energy is a great feature available in all of our Gen 3 hardware and beyond, and it's gotten also a major upgrade in the past year. We've added LESC, which allows you to create a encrypted connection between your device and another sensor in the field. We've introduced coded PHY, which allows you to create long-range BLE connections with sensors that are outside the normal range of a BLE sensor. And we've also heard your feedback about how difficult Wi-Fi provisioning can be on some of our devices. And with the introduction of the Photon 2 and P2 modules, we're working on an easy BLE-based provisioning system for Wi-Fi credentials for you and your customers. And finally, you've heard a bit about EtherSIM so far during Spectra, but I want to talk about it a little bit here. It's our modern connectivity solution for your globally deployed fleet. It offers better back-end tools that help you manage your fleet out in the field with shorter activation times and usage monitoring, and offers up to 350 globally available carriers. It's now shipping with all of our cellular products, and as Zach and Adam shared yesterday, we have an exciting update. We've just added 63 new countries with Cat 1 coverage, bringing our total to 82 around the world. And also, we're targeting a Cat M1 expansion to other countries next year. All right, we've talked about a bunch of cool stuff. I've thrown a lot of information at you, but the best part about most of these things is that you're probably already using them. If you're buying our latest hardware with EtherSIM, or you're using our latest version of DeviceOS, most of the stuff is already transparently available to you. And this goes back to the continuous investment piece. We're continuing to innovate with new updates to our device operating system, and we encourage you to do the same. Please watch our DeviceOS GitHub page. We have an ability to sign up for email notifications when a new DeviceOS is released. And we encourage you to set up a process with your engineering teams to validate new releases of our DeviceOS with your user applications and keep your fleets updated over time. Also, a reminder to check out the new tools section of our documentation. It's available in the navigation bar at the top, and check out some of the awesome things that Rick has built. All right. So far, we've covered a lot of foundational features that are built into our cloud offering and with DeviceOS, but we're going to take it up one level and talk a little bit about Tracker Edge. Now, for those of you who have not worked with our tracking system, Tracker Edge is a particle-managed, tracking-specific reference application that runs in user space on our modules. The goal with this was to create a solution that demonstrated a number of out-of-the-box capabilities of the Tracker One with minimal configuration, and also to provide a blueprint for custom tracking applications of your own design. It contains all the example code that you need to make use of the Tracker module, including GPS drivers, location publishes, and the ability to add user-specific data payloads to them, a configuration service, sleep management, and a whole lot more. Now, to date, Eric and his team have invested hundreds of hours in building the features of Tracker Edge. That's 12,000 lines of codes that your engineers don't have to go and write. It also includes 5 particle maintained libraries, and soon to be more as we expand its functionality, which you'll see in a little bit. Now, all of this we've built so your technical teams can spend less time building building things in the weeds with drivers and dealing with low-level tasks, and more time building your business applications and spending effort connecting to your machines. Now, I'm really excited today to share with you some of the new features that we're going to offer in Tracker Edge. We believe these features are going to take our tracker to the next level, making it more flexible, more accurate, and even easier to use than it already is. Earlier this year, we released an edge geofencing feature, and if you haven't already taken advantage of it, I encourage you to check it out. This enables your fleet to take actions triggered by a set of predefined location zones. I'll share more about that and something new there in just a moment. The rest of these features, fast GNSS time to first fix, dead reckoning support, and store and forward, are brand new features that we're excited to roll out to Tracker Edge, and to your fleets. So let's dig into each of these in more detail, and I'll show you how we're making it really easy to use them. First, we're going to talk about edge geofencing, and I specifically want to highlight the edge part. Our solution is unique from others in the market because it doesn't rely on connectivity or other cloud resources to operate. Now, to illustrate why this is important, let's take the example of an e-bike fleet that's deployed in San Francisco. City regulations mean that as an operator, we might need to limit the speed of those bikes when they go into the parks or other zones to, let's say, 10 miles an hour. Now, with cloud geofencing, you're relying on connectivity and a fast round trip time to the cloud, as well as resources being available in the cloud. Now, I'm illustrating the former of those in the diagram to the right. In this example, seconds can make the difference between safe and unsafe operation of your fleet. Without the guarantee of always-on coverage and perfect uptime for your backend, bikes might be blasting through the parks at full speed, or you might have to take a conservative approach and limit them well before they ever reach the zone, leading to a frustrating user experience. However, with an edge geofencing solution, the bike becomes a completely independent entity that can slow down and take other actions in response to its location. The cloud can find out well after the fact that that action was taken and act more as a log rather than being part of the critical control loop. This decreases your data requirements, your reliance on connectivity in challenging environments, and also increases the response time of your overall system. Now, why doesn't everyone do this? Well, edge geofencing is a complex problem, which requires knowledge of GNSS systems, geometry, statistics, and a number of other subjects. But the best part about it is you don't have to worry about any of that. We've solved it, and we've made it really easy to use. So how do you take advantage of this feature? Well, if you've already downloaded V17 of Tracker Edge, it's already in there. And all you need to do is configure up to 4 point and radius zones in the console with no firmware required. And I'm showing you an example of this on the slide on the left here. You can set up the point, the radius, as well as whether you want a publish when the device goes inside, outside, enters, or exits a particular zone. Now, if you want to set up custom actions, like let's take the speed example that I just went through, this can be handled through a simple callback method in Tracker Edge. And I'm showing you an example of what that looks like on the right. This is actually code that's in Tracker Edge right now, and you can modify this code to meet your use case. All right, so something really exciting here. We've heard your feedback, and we are introducing support for polygons in our Edge geofencing engine. This is going to allow you to define more granular zones of operation for your tracked fleet and give you more control over how your fleet operates in the world. Each polygon is going to support up to 20 points, which allows you to define moderately complex zones. And also, if you want to combine multiple and you have something of very complex shape that needs to take multiple, you can use more than one zone. The best part about this, though, is that it works just like the existing geofence engine. The console API configuration all is going to work the same, as well as the same callbacks in Tracker Edge. So pretty much, just by configuring the points, that's all you need to use to make use of this feature. We've tried to make this as seamless as possible to take advantage of. Now, this feature and the other ones that I'm going to talk about in a bit are all going to be released later this quarter, so keep an eye out. Now, something I didn't mention earlier, but I'm also really excited about, is support for device-level configurations in our configuration service. Now, our configuration service, if you're unfamiliar, is something we debuted with the tracking platform and is an easy way for you and your customers to configure device parameters fleet-wide. Some examples of this might include enabling or disabling sleep, setting up motion thresholds, or other values you might want shared across all of your devices. As we and you have used this feature, we've seen the power in providing the same configurations at a device level as well. Our geofencing engine takes advantage of this in particular, as geofences may need to be set for either an individual device or for an entire fleet, but that all depends on the application. Now, this isn't just useful for geofencing, you can also take advantage of this feature for your own use cases as well. At a firmware level, you can define parameters with different data types, integers, strings, booleans, and a number of other ones. You then upload a schema defining those parameters and whether they are device level or not, as I showed in the previous slide here with that red line of text. And then you upload that to your product. And after that, all of your configuration options become available in the console and also through our API. We have some awesome tutorials in the docs on how to do this, and I'm going to give another shout out to Rick as he has included some great schema management tools, one of which I'm showing right here, that makes setting up the config service a breeze. All right, let's move on and talk a little bit about battery life. I know this is extremely important to many of your tracking fleets, and we're excited to help your devices last longer on battery with improvements to GNSS lock times. And what we've done here is we've leveraged some advanced features of our GNSS chip that automatically store critical positioning information when the device goes into a sleep mode. And then when it wakes up, the GNSS is able to use that information that's been stored to provide an assisted fast startup because it knows where most of the satellites already are. Now, as an anecdote, I've been using this feature for a few weeks as I've worked on a few customer proof of concept devices, and I've seen my initial GNSS fix times improve from 30 seconds or more to 10 seconds or less. That's a significant improvement. Now, what this means is that you can have battery savings. You can spend more time asleep and less time awake. And also, you can have improved data quality for your fleet. You'll know where your assets are more quickly and more accurately upon wake. In my example, I have an e-bike, and when I get out on the road, I can see where it is right when I exit my apartment rather than knowing when I'm already riding down the street. Now, how do you use this feature? Keeping with our principles of making this platform as easy to use as possible, we're introducing a very simple API object that allows you to turn this on and other features that I'm going to talk about today with only a few lines of code. Pretty awesome, right? I'm showing an example of this on the right. Let's move on to talk a little bit about dead reckoning. From the conversations I've had with many of you, I know location accuracy is a really important differentiator for most of your customers. With the addition of dead reckoning support, we're excited to extend the already excellent GNSS performance of our tracking products into even more challenging GNSS environments. For those of you who are unfamiliar with dead reckoning, this is a way to combine other sensor measurements, which in our case is a 6-axis IMU, with the GNSS data streams coming from the satellites using a statistical model in a method called sensor fusion. This allows for more precise positioning results because what we're doing is we're taking the dynamics of that particular asset into account when we're trying to figure out where it is in the world. This also allows for positioning to be extended. So in the case that I'm showing on the right here with an urban canyon, or perhaps your asset is moving through a tunnel, you're able to use those dynamics to predict where that device is going to end up based on its movement, even when you don't have satellites available. All right, so you've seen this story before, but how do you use this feature? Well, it's the same method. With the same configuration object, you're just going to write a few lines of code. You're going to select an appropriate dynamic model for your asset, of which there are a number that we're going to provide. You're going to give information about the tracker's orientation and the position of it on the asset with reference to a specific point on the asset, and then enable the feature, all just in a few lines of code. We can't wait for you to try out dead reckoning and fast time to first fix in the world. And again, these are great examples of a continuous improvement philosophy that we have here at Particle. And they're a great way for you to offer a continuous value stream to your customers without having to deploy new firmware or a new hardware, and instead just deploy new firmware. All right. And with that, I'm going to hand the reins over to Eric Brisseth, who I'm very excited to have with me today and talk about something that he and his team have been working on, which is Store and Forward.
Sure. Thank you, Dan. Well, I'm happy to announce that we're working on Store and Forward, and this is a store publish message system that works for times of poor connectivity so that messages can be stored in the file system and then later retrieved when you're back online. And essentially, messages aren't able to be published or identified and sent to the waiting queue on disk. So this feature employs a new framework for disk queuing, as well as refactored publishing code that already is on Tracker Edge. And so using this feature should be as easy as just clicking a few things in the configuration panel. Next slide, please. So the Tracker Edge is undergoing quite a bit of a transformation at the moment. And so what this means is that we're kind of rearranging some of the building blocks of Tracker Edge. And we're trying to reuse some of these components for Monitor 1 and Tracker M. So the work kind of involves breaking some of these components into functional parts of the design into general purpose components so that we can then make on their own and kind of set up like unit tests and separate libraries and stuff like that. And they can be generalized for use in other platforms, as well as, just being able to be used on certain platforms that are kind of derivative of Tracker. So that was kind of like the main purpose of some of this refactoring. So we wanted to break it up so that it is unit testable, as well as just kind of general purpose, so that you can then take this part, put it into a different platform, and use that as like a standalone disk queue if you wanted to. Or in the case for Store and Forward, we made this disk queue class as well as a kind of like a general purpose background publisher. And next slide, please. So the challenges that we had with Store and Forward were in the config service. And so this config service was broken apart, and it was broken apart into a config and a cloud service, as well as a background publisher. So this background publisher is basically it's a class that handles like low-level calls into device OS, and combined with a disk queue, this disk queue that essentially acts like a C++ standard container, will enable us to go into store and forward. And so the store and forward is just a combination of these two systems to allow you to put things on a disk when connectivity is poor, and then bring them back out of disk when you have connectivity again. Next slide, please. So the background publisher class, it kind of manages the device OS access into the published message queue. And so device OS has its own queue, a very small queue that is somewhat rate limited. Well, we put an extra layer on top of it, and this extra layer on top of it kind of manages one publish per second rate limit, as well as allows us to inject higher priority messages that may come from your application with the lower priority messages that may come from this disk queue that is operating when you come back online again. So you might have a bunch of messages that are kind of stored up on disk, and you want to send them sequentially, once per second for, how many ever seconds that you have for messages that you have stored offline, and these could kind of conflict for this rate limit. So we just have this mechanism that would allow you to insert higher priority messages and get them out of the application, and then leave the disk queue for lower priority transmittal. And so the queue can be sized, tens of messages, hundreds of messages, thousands of messages, depending on the configuration that you set. And so you can imagine that as it's unloading this disk queue, there could be quite a bit of data that is sent out of this. So we just wanted to introduce that priority queue just to make this easier. And next, please. And then, so the configurations that you're going to see that are new to store and forward are enable, of course. So when it's enabled, the disk queue is utilized, and when it's disabled, it kind of returns to the original feature of Tracker Edge, which is try to publish, but if it doesn't publish, then it goes on its way. Of course, the size is the size on disk, or the storage size is the size on disk, and this is basically a quota that says that you can have X amount of space on your disk for this queue. And so if your publishes are around 1024 bytes, then a queue of like 64, which is the default 64 kilobytes, that would save about 64 messages for you to send out. And so this may vary by application, by your needs. So we allowed this to be configurable by you and controllable by you. And then the last thing is the policy, the disk queue policy. And so if the disk is ever full, we want to give you the option of either deleting new entries or older entries. So the default behavior is actually to delete old entries. And that will allow you to, stuff away newer entries and make sure that that you always keep the freshest, newest data available. Next, please. And some of you may actually be surprised that we actually have a file system on our platforms. And so Tracker M, Tracker 1, Monitor 1, Boron, Argon, they all have their own file systems. And Tracker 1 has a 4 megabyte file system, and Boron, Argon have 2 megabytes. So this file system is made up of little FS. So little FS is a kind of a robust, wear leveling file system that is meant for kind of embedded applications. And so for more information, you can go to our website, our documentation website, and we actually have some use cases for that. I believe in device OS 2, 2X, we actually introduced some additional POSIX type of file functions that allow us to have better access to the file system. So check that out if you have time, if you're just curious on the file, general use of the file system. So store and forward, of course, uses this particular file system for its own use. So we have a couple of directories. We have a user directory and we have a system directory. And we highly recommend that you store any of your application data in the user directory. And the purpose for this is to avoid inadvertent writes or deletions of files on that file directory, or above that file directory. The system directory is typically used for storing kind of device state and other configurable parameters that is used by device OS. So you definitely don't want to monkey around in that directory. And so the disk queues are essentially put into the user path, and they are named. All the disk queues are actually named. And so for the purpose of Tracker Edge, we named our location queue LOC, or LOC. And so that kind of mirrors the particular published messages that come out of Tracker Edge. Next, please. So a little bit about policies. So we do employ like a first in, first out queue for our disk queue. And this is similar to C++ queue containers. And so the containers usually have a front and a back. And so in the case for our queue, you always push to the back and then you pop from the front. And so on the back is essentially where new entries go into, and then the front is where older entries or the oldest entries actually come from. So the two policies are discard newer or discard older. And so for newer items, if the queue is full, then the newer items that are going to or meant to be put onto this queue are just dropped. So it means that you have a lot more value for older data than the newer data, and just simply drop new messages that go onto this queue. And again, your application may warrant a different use of this or a different strategy. So the default behavior is actually to discard old items, whereas if the queue is full, the front is popped and entries are actually discarded from that side. And then when you come back online again, the current the current front pointer or the current front of the queue is then unloaded into the publish queue and then sent out in this low priority queue in the background publisher. Next, please. So, I hope this gives you, kind of a good preview of the store and forward. We've added the disk class or disk queue class. We've refactored existing code and, added unit testing to reliably determine, build success, integration into continuous integration systems. We've introduced the background publisher, a standalone class that is responsible for reliably determining publish success, and then we have a plan to make Tracker Edge more modular and general purpose, especially for Monitor 1 and Tracker M, and then for any of your general purpose platform needs. So we're targeting all of this in Q2. By the end of the Q2, and which should be in Tracker Edge version 18. And so the firmware used on Monitor 1 and Tracker M will start right out of the box using this framework. So keep an eye out for the Tracker section in our documentation website. Just take a look at the link on the screen there. And visit that every once in a while. Also, GitHub has a subscribe for notifications for changes on particular repositories. Please go ahead and take a look at your GitHub notifications. So whatever we do on Tracker Edge, you can get notified of any changes. And then if you drill down into some of those libraries in Tracker Edge, you'll see some of the dependencies that we use as kind of like a base for Tracker Edge development, and then you can then set up notifications for those particular sub modules as well. Okay, well, thank you very much, Dan.
Thanks, Eric. We're really excited to roll out Store and Forward and the other features that we've shared today to your growing fleets. And with that, I'm going to close out and do a quick recap of all the exciting things that we've announced today. But actually first, I'm going to do a quick plug about a reference application that I've been working on that's built on top of Tracker Edge. So we've announced a bunch of really powerful, really easy to use features, but we've done so all in isolation. And to demonstrate these features in a real world application, I happen to have an electric mountain bike, which is a perfect platform to test almost everything that we've shown you today. In a few days, and just 400 lines of code, I was able to tap into my bike's CAN bus, connect it to my Tracker 1, and get it talking to the Particle Cloud. Now, my reference app includes a few new features here. So the first is wake up and sleep based on CAN activity on the bus. So when I start my bike up, the tracker is automatically going to wake from sleep and start connecting to the cloud, get a GNSS fix, and begin to publish. And also when I turn my bike off and I've arrived at my destination, the tracker is going to go to sleep after a configurable interval. Also, because I'm connected to the CAN bus, I'm processing, storing, and acting on all the data that's being presented on the bus. You can see some of that in the example that I'm showing down there on the right, which is a ride that I did yesterday. So I'm measuring the battery percentage, the voltage, the current, and the speed that I'm going. But there's a lot more that's accessible there, and it's really easy to use the various CAN codes that are available to pull that data off the bus. And then I'm also using that CAN data to configure various publishes, so setting various states of activity of the device based on that data. In my case, I'm saying that the bike is active when I'm riding over a certain speed, and I trigger publishing at a regular interval in that case. And when the bike is not moving, I switch back to a slower publish rate to save data. Now, I'm talking about a bike here, but this literally could be any CAN-enabled piece of equipment that's out in the field. And myself or anyone on our team is looking for customers with mobile assets that leverage CAN bus. We would love to work with you and do a workshop with your technical team, whether that's in person or remote. So please reach out if you're working in one of these spaces. We would love to get you and your devices on a map. All right, we've covered a lot in this session. Let's recap quickly, and then we'll move into our Q&A session in Slack. First, we went through a brief overview of our platform as a service offering. We're more than just hardware, connectivity, and cloud, and we actually make it really easy to build prototypes and scale your fleets with reference designs and an expanding set of cloud and firmware features. We then took a look at the number of platform updates that we're making, or that we've made in the past year and are making in the future, including resumable OTA, advanced BLE features, increased published payload sizes and flash space, as well as our powerful EtherSIM offering. Next, we dove into the exciting updates for the Tracker platform enabled by Tracker Edge. This includes polygon geofencing, device-level configurations, and some advanced GPS features such as fast time to first fix and dead reckoning. Eric then went through a deep dive into our Store and Forward library, which is debuting in Tracker Edge and will be available for use on all modules in the future as a library. And lastly, I shared some work that I'm doing to make it even easier to bring CAN-enabled mobile assets online with a reference application built on Tracker Edge. If you want to take advantage of any of these features, please reach out to us at sales@particle.io. Myself and our team look forward to learning more about what you're building and how we can support. And one last thing, the technical sales team at Particle is hiring, and if you have a technical background and are looking for a customer-facing role, we have multiple open positions on our team. We have an awesome job here at Particle and a chance to help all of our customers across all of our industries along their IoT journey. If that sounds interesting to you and this seems fun, please come talk to us.